All right, I'm showing 10 o'clock. Let's go ahead and get started. Want to welcome everyone and thank you for joining us. My name is Sean Davenport Smith, sales engineer here at Long. And today I asked Mr. Bob Ellis with Raypak to come on and talk to us about some of the unique features of Raypak's condensing boiler line, and specifically dynamic protection and how it can benefit the hydronic flow of the boiler and protecting the boiler. So with that, I'll turn it over to Bob and we'll get started.
Hey, everybody. I hope you got your cup of coffee. I certainly have mine and I'm ready to go. Want to talk to you guys and share something that's pretty near and dear to me as far as, having been in the boiler business for quite a long time. Well, I've been with Raypak for over 23 years now, but we've seen the evolution of boilers in the industry go from we're talking stainless. Well, actually, it was a cast iron, high mass, steel tube, fire tube, so water backed fire tube, etc. So we've seen the evolution, and of course, didn't have a lot of problems with those units. They weren't that deficient. A lot of them lasted for many, many years. Of course, we'd have some of the basic issues that are associated with them. But when we started seeing more and more stainless steel, the condensing style, we started seeing some very distinct issues. So that's what I want to talk to you about. I want to talk to you about, how systems, for years and years, as I mentioned to you about the steel tube or the fire tube or the cast iron type boilers being high mass, most of those systems were piped in a primary configuration, which is basically what is shown here. And of course, nowadays, you add variable speed pumping to that, and that's what we call variable primary flow system. So there's a lot of advantage to that. If you go from, say, primary secondary to primary or variable primary, well, you don't have a lot of different separate piping coming down for each boiler, and then you don't have a pump on each boiler. So maybe you have a little bit of a reduced power consumption, but it certainly simplifies the overall piping of the system and helps to possibly reduce some of the front end costs. But of course, along with that, as you get into applying stainless steel, then that's where this is where this becomes near and dear to my heart. So, and I want to show you, first thing first is bear in mind that when you're talking about the heat transfer coefficients or the thermal conduction properties of the materials that the equipment is made of, you notice that by far and away the best, as far as commonly used in boilers or hot water, the best heat transfer material is copper. But of course, as we get into high efficiency type of equipment, copper isn't going to manage the condensate. So that is where we see a lot of stainless steel here coming into play. But if you'll notice in the thermal conduction properties, it has the lowest heat transfer capability. So you have to use more of it. It's also going to stress more if you put too much heat into it. So giving you that a little bit of background there. Here, so if you use a stainless steel boiler, which is a vertical stainless steel fire tube condensing, which is the primary unit that I'm talking about. And honestly, the design is outstanding for that. When you consider your condensing in a boiler, you certainly don't want that the products of combustion, the condensate, when that unit is running at peak efficiency going back into the burner. So making it vertical and making the condensate flow to the bottom of the pan for the flue is ideal, keeping the burner at the top. And they're high mass, so they're a little more forgiving to flow. So you put that into a variable primary piping loop, and everything is great. If you maintain nice return, low water temperatures, you're going to maintain peak efficiency on the boiler. However, one of the things you've got to bear in mind with stainless steel is that it absolutely does require a minimum flow of some type in order to keep the heat transfer proper. When that unit is fired, you want to have a minimum flow. And if you have glycol in the system, that's going to impede the heat transfer. It's going to make the fluid that we're trying to push the heat into more viscous. So consequently, what's going to happen is the heat transfer is going to slow down. So what I'm showing here is a system with basic fan coils and two-way valves. And this is something where I know that you guys probably wouldn't design it this way, but let's just say that this was a retrofit application. And nobody really paid attention to what was going on in the system. Here's your boiler room. Well, actually here's your boiler room over here. And this is your system. Nobody's really looked at the coils. They put the stainless steel fire tube in, and of course nobody's really complaining because that boiler it's going to ramp up and down, and the pumps are going to ride on their curve. But as these valves begin to close, then our pathway back to the boiler in order to maintain minimum flow is definitely reduced. If we don't have enough three-way valves here in the system, say that there are some three-way valves, if there are not enough of them, again, if the boiler doesn't get its minimum flow and there's a call for heat, it will begin to stress the heater, especially if the heater can't monitor its own flow rate, GPMs. So the other thing that plays into that is, where is this sensor located? If that sensor isn't located close enough to the outlet of the heaters, if it's located a little further down the line and it's calling for heat, and there's lower flow, well, that's going to also impact the way that heater operates. So, you kind of get where I'm going with this. Now, having said that, I mentioned dynamic protection and dynamic protection. And why is that important? It's so, I say so important. It's because, we're trying to protect this very expensive heat exchanger. Stainless steel would seem, impervious to anything. It's like should never fail. However, the weak points are there are some chemical vulnerabilities to it. However, the primary vulnerability to this heat exchanger in a hydronic system is going to be the heat stresses, and that's something that the people a lot of times don't think about. So one of the way that we have addressed that, come on, there we go, is if you'll notice here, on the inlet to the what we call our X-verse with core, there is a flow meter, and it is actually measuring the GPM of flow going through that heater at all times. That information is going to our controls, and it is integrated into the controls and the programming of the controls, because each one of these units has been very thoroughly tested. There's been a very deep dive analysis done on heat stresses and determining what is the minimum flow required for that unit to operate at different firing rates. If there isn't enough flow going through that unit, then we make sure that unit doesn't operate so that it does not cause failure to the heat exchanger. Let's see. So again, that's where that flow meter is on the inlet side. Now, one thing I'll mention about this, just as a side note, is that when you're dealing with flow meters, naturally you want laminar flow. You don't want turbulent flow going across that flow meter in order for the reading to be as accurate as possible. So, our O&M manual states that you need at least 20 inches of straight pipe on this, or you use a suction diffuser. Most cases, people use suction diffusers just because it requires the least amount of space. Now I'm going to play this video for you. It will kind of help give you a visual of what's going on inside that heat exchanger and what it is we're doing with this this flow information.
Raypak Dynamic Protection safeguards your investment and eliminates the worry of unexpected condition changes by managing the performance of the unit automatically. Raypak Dynamic Protection's advanced and patented controls algorithm maintains the optimal performance by adjusting the firing rate based on real-time flow rates. Where other boilers on the market maintain the same firing rate during undesirable low flow conditions, which will result in increased stress on the heat exchanger, Raypak boilers with dynamic protection will reduce the firing rate as the flow drops below the desired level, ensuring a new optimum operation point. During undesirable low flow conditions, the heat exchanger will experience higher levels of stress. Raypak Dynamic Protection's advanced and patented controls algorithm responds to usage and demand and automatically adjusts, keeping the unit at optimum performance. With Raypak's Dynamic Protection, you will have peace of mind knowing you won't have to sacrifice the life of your boiler or the uptime of your system. To learn more, visit raypak.com.
So that gives you a real quick overview. That's a YouTube video that you can access at any time on our YouTube channel. But the other thing that is a part of that dynamic protection is, well, obviously we're looking at delta T on those units as well. But there, in the way that unit operates, we're also taking into consideration glycol. Now, if you haven't compensated for the flow rate going through that unit, for the the glycol, that is the concentration in the water, you can program that in the commissioning process, and we'll take into account how much that reduces the heat transfer so that we don't overstress that heat exchanger. Because the bottom line is if you put more glycol in the system, doesn't matter how many BTUs that boiler is capable of, unless you are pumping it faster, you won't be able to transfer the heat into the water, and it will therefore go into the material and just stress the heat exchanger. So the goal of this, the bottom line goal, is to ensure that we maximize the lifetime of that heat exchanger. And I can tell you today, in the 5 years that we've had the X-Verse and the X-Verse with core out, we have not seen a single heat exchanger failure. So I'm extremely, like I said, it's near and dear to my heart, because that is the primary reason that stainless steel, fire tube, condensing heaters, heat exchangers, that's the primary reason they fail prematurely. So with that, I'm going to turn this over to Sean and let him continue on.
Thanks, Bob. I just had a few other discussion points I was hoping that you could bring up about it. Obviously, the dynamic protection, the first and foremost is for protection of the heat exchanger and extending the longevity of it. But what are some of the other benefits that an owner or engineer or installed contractor can see with it and utilize for having this boiler in their system?
You trying to give me a trick question there, Sean? No, honestly, if you have a BMS system, one of the nice things about our equipment is that naturally you can integrate into the BMS port on the unit, and you'll be able to see all of the points that we're monitoring, including flow. So you could take that flow information off of all connected units and provide yourself with the total amount of flow going through the unit. The other thing about this is if they are cascaded together, and the master, you say that you're running on one boiler, if the system is calling for additional heat, the heater, the master will not allow the second heater to come on unless there's adequate flow for the second heater to come on. That's probably the number one cause of failure in multiple boiler systems, is that when the second boiler comes on, if there's no way to monitor what the total flow is, and all of a sudden now you're splitting the flow in half because you have two boilers fired, that's when you see your greatest stresses on the heat exchanger. But being able to monitor the flow off of your BMS and see what's going on. You can diagnose a lot of information. You can diagnose your system better with that capability.
Yeah, I was thinking, being involved with a lot of boiler projects, there's a lot of troubleshooting, and a lot of times it does come down to flow. Most other boilers, including this boiler, also comes with a flow switch that only gives you so much information. That just tells you that you have enough flow to meet that switch. Doesn't tell you the exact flow through it. But also with having the flow meter in there, you can actually measure the actual output of the boiler with the delta T and the GPMs going through it. So you can make sure it's running as efficient as you expect it to and do a lot of troubleshooting. So
You're
I think it's a really
100%.
cool feature.
Yeah.
And it does come standard on all the Experts core products, and then it is an option that could be added in the Experts L and other condensing products. So very good benefit for those boilers there. So I appreciate your time, Bob. I really appreciate it.
Guys, the reason that we don't put it as a standard, you just heard me talk about the value of it. The reason we don't put it standard on the Experts L, which is the smaller sizes of the fire tube, is because it's really a cost point. It's a market cost point, but it certainly is available as an option.
Exactly. So I appreciate it, Bob. Join us next week where Ryan Nabowski will be talking about reinventing air distribution. So that sounds pretty interesting. I think that should catch everyone's attention. And thank you again for joining us. Have a great rest of your week.